All right, guys, I'm going to go through a quick projectile motion problem like we've seen in class, just so you can have another example. This one's pretty similar to the one you saw in the quiz, just different numbers so that you can kind of get familiar with stuff before the test. So I have a girl, and she's going to run at a speed of 4 meters per second off of a high dive. She doesn't jump. She's just going to run straight off the edge of the board, and she's in the air for 3 seconds before she hits the ground. I want to figure out how high the diving board was from the water. Okay, that's going to be delta y. I want to figure out how far away did she land. Did she land? That's going to be a delta x. Okay, that's just what I'm going to figure out for this problem. Let's write down what we know. I know velocity initial in the x direction is going to be 4 meters per second. That's given. I know that time in the air, or hang time, is going to be 3 seconds. What else do I know, just from projectile motion? Well, if I go off to the side over here, and I draw an FBD, I can see that the only forces while she's in the air, say when she's over here, is going to be the force of gravity. So since the sum of the forces is only equal to force of gravity, my acceleration must be gravity. Okay? So my acceleration in the y direction is going to be gravity, or about -10 meters per second squared. Okay? If I look back over here at my FBD, I see that there's no horizontal forces, which means I have no horizontal acceleration. It's totally balanced in the horizontal direction. So my acceleration in the x direction is going to be 0. Great. Let's see if we can figure this out from this information. Oh, and because my acceleration in the y direction is -10, but I'm starting off with only horizontal motion, I know that my velocity initial in the y direction is going to be 0 meters per second. Great. Now we have everything we know. Now let's solve for how high she fell, how high the diving board was. I'll look at my formula sheet. I know velocity initial, I know time, I know acceleration. I'm looking for delta y. Easy peasy. We can use the same formula we've been using most of this unit. Delta y equals velocity initial in the y direction times time plus 1/2 acceleration in the y direction times time squared. Okay, I want to solve for y. Oh, it's already isolated. Great. So I'm just going to plug what I know. Velocity initial in the y direction is 0 times time. So we don't care about that, plus 1/2 -10, time in the air is 3 seconds squared. Let's plug that into the calculator. So I'm going to end up with delta y is going to be equal to -45 meters. Now, the reason it's -45 instead of 45 meters is because I'm saying this position here is 0 meters. So if I go anywhere below, it's going to show up as negative. But if you just put 45 meters on the test, I would accept it. Great. Still have another half of the problem. Where did she land? Just give ourselves a little space here. I need to find delta x. I know velocity initial in the x direction. Given to us. I know time. I know acceleration is 0. Let's plug and chug. Same formula we used before. Delta x equals velocity initial in the x direction times time plus 1/2 acceleration in the x direction times time squared. Velocity initial we have. So let's start plugging things in. So we have 4 times 3, because that's how many seconds she was in the air, plus 1/2 times 0 times 3 squared. We have a 0. Cancel it out. So delta x is just going to equal 12 meters. Awesome. Hopefully this problem has been helpful to you. I'm going to do another problem that helps us solve for a couple of different things, but if you're looking for just distances, this is a great example.